This video is part of Project 6, and for this part we will be making the rim for our wheel assembly. This part of the project is fairly simple, and you can see from the feature tree that it only takes about 8 or 9 steps to create. The rim is just a revolve hoop that has a hole or series of holes in it, one for each spoke that will be going into the wheel assembly. It also has some details on the rim that capture or clinch the tire onto the rim so that it doesn't easily come off. Taking a look at the rim in the wheel assembly, the spokes are evenly spaced all around the perimeter of the rim, and there are as many holes in the rim as there are in the 2 flanges on the hub. This example here shows 36 spokes total, so there are 36 holes in the rim, and we also have a hole in the rim to allow the valve stem to pass through. If we take a cross section of the assembly, you can see the cross section of the rim here in purple. This is the detail that clinches on to the tire. This is the hole in the rim that allows the spoke nut or nipple to pass through, and this is what anchors the spoke into the rim. Then we have a slightly bigger hole which is used to create clearance for the anchor end of the nipple. Even though you are going to be designing a custom rim, one set of features you will not be altering are these details that clinch onto the tire and this back wall that the tire seats against. You are going to be building this model using the master model technique, and you will be using the same master model that you use for your other parts such as the hub and the axle. Before you started this process, you should have decided how many spokes were going to be in your wheel and what type of rim you were going to have. Traditional older bike rims have a very boxy shape like this, or perhaps like this, and they are only about 11 or 12 millimeters tall in this dimension, perhaps 15 at the most. They also have a double wall section, as you see here and here. When we model our rim, we're just going to leave this filled in as a very thick wall. The newer, more aerodynamic rims tend to have a deeper cross section, as much as 20 to 40 millimeters deep, and have an airfoil shaped cross section. Quite often, even though they have a curved airfoil cross section in this area, they will have vertical walls here and here where the brakes can engage. Often there's a little step right here to differentiate the area where the brakes engage, and the nice area here which is often anodized with some type of color. At the extreme end of the range are arrow-shaped rims that have a 40 to 60 millimeter depth and get very narrow and tapered at the end. And again, you see that these often have flat sides for the brakes. Although I've seen ones that are 60, I think 40 would probably be the more practical limit for this project. Typically, the deeper the cross-section of the rim, the fewer the spokes that you need, because the rim becomes very stiff as it becomes very deep. However, for this project, the way I've constructed the models, 24 spokes is the fewest that we can use. Now, getting back to our master model, you have to have decided ahead of time whether you want a rim with boxy proportions, which are the dimensions represented in your current master model, or if you want a deeper aerodynamic rim. If you want a deeper aerodynamic rim, you want to go to the rim and tire diameter sketch and edit that, and change this rim depth, which is currently at 11 millimeters. I'm going to change my rim depth to about 35 millimeters. We can see how deep that rim is now compared to the tire. And because I've got a deeper rim, I think I'll have fewer spokes as well. So I want to go into the spoke sketch, spoke layout sketch that is, and edit that, and I need to change this spoke angle. The spoke angle is equal to 720 divided by the total number of spokes. editing this dimension, I'll type in 720 divided by 24 spokes. We see the spokes spread out quite a bit. And now I have a master model that's ready to be used in my rim. If you already made some other parts for the wheel, such as the hub, you should have gone through this process first before making those parts, because that will affect the number of holes in the hub flanges. The next thing to do is create a new part. And we might as well save this right now. Call this rim. And our first step in the process is to say insert part. We have to browse to our master file, which we find here. Open. Make sure that unabsorbed sketches is checked and check our green check mark. And here we see our master file. We see that the rim depth has been updated on it. For step 2, I'm going to create a convenient axis that can be used for revolving. I'm going to have that go through the intersection of the top plane and the right plane. And before I go any further, I'm going to get rid of some of the sketches that are not necessary to make this part. Clicking on the plus sign here, opening up the folder for my sketches. I don't need to have the hub cross section, the hub bearing area, the sprocket layout. That leaves me just 4 sketches that are related to the creation of the rim. Next step now is going to be to create 1/2 of the rim itself. Zooming in here, we see that when we changed the sketch for the depth of the rim, it automatically also updated the sketch that represents the cross section of the rim. So creating on our top plane a new sketch. I'm going to copy the details that must be in our sketch cross section, and these will be the details that clinch the tire onto the rim. So using convert entities, I'll copy these items. And going up here, this is where the innermost part of the rim is located. The spoke passes through here. I'm going to copy this line as well. But I want to make a more aerodynamic shaped rim. I want to put a little step here like you saw on the other examples, and then have this sort of arrow shape kind of coming up like this and wrapping around. So I'm going to add another line here. And add a spline. And I'll stop it right about here. Trim away the excess. And then start playing around with the spline here. I think I'll make this a horizontal relation. The step only needs to be about 1/2 millimeter at the most. I'll add a dimension here of about 10 millimeters, somewhat arbitrary. And I want to have a little bit of a flat area here so that that hole passing through has a flat section to go through. So I'll make this about 3 millimeters, and I'll make this a vertical relation. Let's take a look at that directly. There's my aerodynamic shaped rim. I can maybe make this 2. This is the larger hole that's going to be going through to anchor the back of the spoke nut or nipple. So we want to make sure that this does not cut through. Otherwise, we need to make this hole go a little bit deeper, which might be acceptable. I'll bring this to here. And finally, I think I'll add a little fillet to this corner. That's too big, so we'll make that about 1/2 millimeter. That looks good. So this is the section we're going to revolve. There's one last thing we need, which is a line going across here to finish this closed off area. So now we can finish the rim just using the revolve base command. Our axis of revolution will be the axis we made in step 1. Let me hide everything for a moment, and here we have 1/2 of the rim that includes the clinching detail that grabs onto the tire, and this is the back wall that the tire seats against. Our next step is to mirror this to make the entire rim. Using our front plane as the mirror surface, we might want to use the bodies to mirror instead of features to mirror option. Clicking on that body, making sure merge solids is checked. Complete. Now we've got the entire rim. The next step is to put in the first spoke hole. Turning my sketches back on, we're going to use the sketch for this upper spoke to drive the location of the spoke hole. On the front plane, make a new sketch. I'm going to draw a center line. Instead of making it collinear with the spoke, I'm going to make it collinear with this line that starts at the end of the spoke but goes through the center of the hub. This hole then will go normal or perpendicular to the face of the rim. Collinear. We're going to use this axis to revolve a cut hole that will clear both the nipple in this area and the anchor for the nipple in this area. The cross section for that is going to look like this. Making these lines parallel. And these perpendicular. What I want to do is revolve a hole that's big enough for the nipple in this area, which has to be about a 4 millimeter diameter hole. Notice how I'm dragging to the outside here to give me a diameter dimension. And the area that's going to clear the anchor for the nipple needs to be about 9 millimeters in diameter. We can just drag the ends of these well outboard of the rim, but we do need to dimension this location here. So I'm going to dimension from this endpoint that's in the sketch. I'm going to make this about 1.5 millimeters. Depending on the shape of your rim in this area, this might be too thin an area and this portion will cut through the rim. So you can make this section a little thicker if you need to, but not too thick, because the spoke nipple sits against this surface in the rim. If this is too thick, the spoke nipple will be pulled down into the rim, leaving very little of it above the rim to screw onto the spoke. Now ready to revolve this cut. And because I already have an axis in the sketch, it automatically uses that axis to revolve about. Here's my hole for the nipple. Here's the hole that clears the anchor on the back side of the nipple. Hide our sketches again. Zoom in on that hole. I'm going to add a little fillet to that hole if I can, about 0.5 millimeter. Now I'm ready to pattern all of my holes. Remember, I decided I wanted 24 holes. I'm going to pattern that around axis 1. And the features I'm going to pattern are going to be the hole and the fillet, and I need 24 total. But you'll notice that I forgot to click on the fillet, so let me add that to the feature. here we have the hole plus the fillet applied to every single hole. And because the rim is narrow at the top where the hole passes through, you can see that the hole sort of just wraps around the edge a little bit. If you have a very pointed rim in this area, you'll notice the hole wrapping around the edge even more. Again, be careful when you do this cut that it doesn't want to break through to the side of the rim. If that happens, you might need to make this section a little bit thicker. But again, not too thick, otherwise the spoke nut or nipple that anchors the spoke is going to be pulled way down into the hole when you make your final assembly. So here we have the hole, here we have the shape of our rim, and here's that flat section for the brakes. Our final step now is simply to add the hole that the valve stem will pass through, and we have a convenient sketch to help us get that into the right position so it's properly between the spokes. This sketch here gives us the location of the valve stem. And on the front plane, we'll make a new sketch. We'll make a center line, make it collinear to the center line. Then we'll draw a 3-point rectangle. Which automatically gives us these sides being perpendicular, but also allows us to tilt the rectangle on angle. I'm going to drag the rectangle out so that it's passing completely through the rim, and I happen to know that the proper diameter for this hole has to be 1/4 inch, which is equal to 6.35 millimeters. So measuring from here to my center line, dragging out to the side or underneath, 6.35. That's going to be revolved to make a hole cut for our stem. Revolve cut, and here's our hole for the stem. You can see how that just barely wraps around the sides of the rim. And that concludes the creation of the rim for Project 6.